The next type of function we're going to look at is the reciprocal function. This one may be new. You may not have seen this one in previous courses like many of the other ones. The equation of a reciprocal function is f of x equals 1 over x. So the idea is if we input an x value, we output 1 over x, the reciprocal of x. Now this type of function, when the variable's in the denominator like this is a rational function. Rational is another way of saying fractional. We're going to study this whole class of functions, not just 1 over x, later in the course. So we're not going to get into too much detail for now. Just know the general shape here is this. It's these two branches. It has two branches, and each branch fits in the quadrant. So this first branch fits in this first quadrant. It never crosses either of the axes, and this branch fits in this quadrant. It never crosses either of the axes. So there's actually these imaginary boundary lines, these dashed lines at x equals 0, so on the y-axis, and at y equals 0 on the x-axis. So there's like boundaries there that those branches never cross. So you can just describe this shape. You can say the branches, or you can say on here. So we can say branches. Some of my students have called them like boomerangs. And then we have these asymptotes. Again, we'll study this in a lot more detail later, but these boundary lines are asymptotes. So that's an important feature of these. So the domain, if we put our pencil all the way left on the leftmost branch and we trace, this graph goes all the way from negative infinity, but then there's boundary line, this split in the graph. So it's negative infinity, but then at 0 it splits. And then the right branch picks up just past an x value of 0 and increases infinitely to the right. So our domain is negative infinity to 0, union 0 to infinity. So everything except 0. Then the range, again, if we put our pencil at the lowest point, this would be all the way down to negative infinity. As we trace up, we have everything except then we hit this split at 0. And then we pick up just past 0 in the top branch and we go to infinity. So the range is the same. Negative infinity to 0, union 0 to infinity. We can observe symmetry. We can see that rotational kind of diagonal symmetry if we rotate the paper 180 degrees. So that tells us this is an odd function. And if this is kind of deceiving, the increasing and decreasing. Make sure you actually trace this. So if I take my pencil all the way left and start to trace to the right, this is decreasing. Then there's the split. Then I pick up on this next branch and I'm still decreasing. So everywhere that graph exists, it's decreasing. So it's never increasing, and it's decreasing everywhere it exists, which is negative infinity to 0, union 0 to infinity.